I think when I think about new buildings and what they smell like, I definitely think about paint. Also, furniture has this unique smell.
Do you like the way that smells?
It depends on the strength. I feel like if it's too much, it gives me a headache.
You know what produces those smells?
Perhaps the remaining smell that has yet to leave.
Have you ever heard of a volatile organic compound?
Volatile organic compounds? I am not familiar with those.
Does the phrase volatile organic compounds sound safe?
No, it sounds very unsafe.
These familiar smells might follow exciting home and office renovations, but they also indicate the presence of harmful and unnecessary chemicals in the air. These chemicals, known as volatile organic compounds, or VOCs, evaporate under typical indoor atmospheric conditions and are hazardous to humans and animals breathing them in. Why are VOCs so harmful? As their name suggests, VOCs are very volatile. VOCs evaporate very quickly, entering the air and our eyes, nose, lungs, and other parts of the body. VOCs include a suite of chemicals that interact negatively with human biology. Some common VOCs you might have heard of include formaldehyde, propane, benzene, and chloroform, none of which are chemicals you should be breathing in. VOCs also react with other chemicals, creating secondary VOCs and even particulate matter. Particulate matter is a fine dust that is harmful to human health because it is small enough to enter the bloodstream. VOCs can cause irritation in the lungs, eyes, nose, brain, stomach, and nervous system. Some VOCs can even cause cancer, such as benzene. Classified as a carcinogenic VOC by the EPA, benzene exposure can lead to endocrine disruption, anemia, and leukemia, and VOCs generally worsen symptoms for people with asthma and respiratory illnesses. These established risks depend on the concentration and duration of exposure, and can be exacerbated when multiple VOCs are present at the same time, leading to additional health problems.
VOCs are produced in the industrial manufacturing of paints, pharmaceuticals, and refrigerants. One VOC, benzene, is used in the production of rubbers, plastics, detergents, glues, paints, and other industrial products. Traditionally, paint has released many VOCs, including formaldehyde. This chemical serves as a preservative, preventing microbes from growing in the liquid. It produces a distinctive odor we commonly associate with paint. The chemical, however, can last 2 years in some indoor environments. VOC-releasing products like paint are concerning because they continue to release dangerous chemicals at all stages of their lives, increasing dangerous exposure to humans. VOCs are released when paint is produced in factories. VOCs are released when paint sits on the shelves of your local hardware store. VOCs are released when you open the paint can to refresh your family room. VOCs are even released in your garage or basement when that same paint can is gathering dust on a shelf. Why do we find VOCs in so many building and industrial materials? In some products, like scented candles, VOCs are added to produce a certain aroma. But in many other products, these chemicals can be used as binding agents for holding carpets down or in the treatment of lumber. When used inside, VOCs build up. According to the EPA, VOCs can be 5 times more concentrated indoors than outdoors, meaning that they build up in indoor spaces. This problem is worsened by poor ventilation and an excess of products emitting these VOCs.
Despite their presence in many building materials, VOCs are actually not necessary. There has been a growing movement to eliminate or minimize VOCs in different products. 2 scalable solutions are using water-based alternatives and providing adequate ventilation. These methods both work to decrease the concentration of VOCs in indoor environments. To understand how Harvard has reduced VOCs in its buildings, we turned to Heather Henriksen, Harvard University's Chief Sustainability Officer.
So we really have seen a huge shift, certainly in our campus, but even more broadly in the industry, where now it's very easy to find low VOC paint and adhesives and caulks and sealants.
Ms. Henriksen discussed how in the past decade, VOCs are being reduced in building materials, mainly because manufacturers have pivoted to using researched, safer alternatives that are actually cheaper. Harvard has required its manufacturers to be transparent and provide a documented labeling system for the ingredients in their products, especially to understand whether such products are low VOC or are actually safer substitutes. Manufacturers are also producing low and no VOC products in response to market demands. These changes have had real tangible impacts here at Harvard. Using low VOC products in construction and renovation and flushing air through its newest buildings, including the Smith Campus Center and the new Science and Engineering Complex, almost completely eliminated VOCs from their interiors. These methods are easily scalable to other building initiatives.
When you design and buy products that are low VOC, you allow the time for them to also off-gas, that when people come into a space, they can tell that it doesn't smell like something new. I think for VOCs, you can unequivocally recommend to anyone, in all sectors. So not just higher ed or the private sector, but even nonprofits, affordable housing, public schools, that they can get low VOC products at the same price.
Harvard's Healthier Buildings Academy is looking to not only build a healthier supply chain, but a healthier building environment in general.
These changes in understanding VOCs and the movement to limit their use are promising steps forward. To eliminate VOCs, however, we need more companies to commit to these changes. VOCs can be harmful and dangerous, so contractors and suppliers need to implement proven methods for reducing VOCs in the products they use and design proper ventilation for VOC storage. Market and institutional pressure for low and no VOC products show that we have the ability to limit VOCs in our product.
Well, I think that VOCs have had tremendously been reduced in commercial building materials. There is a lot of work to do on education and to get these VOCs in particular out of consumer products.
While our industrial construction processes are showing great progress, commercial personal products such as perfumes and cosmetics still use VOCs in their production. We can and should demand better for ourselves and our spaces. A future free of VOCs could be just around the corner.